9.5 day 2, we're still going to be working with regular polygons. And today, again, we're going to go over a way to calculate the area of a regular polygon and find missing measurements when needed. So just a quick review on the parts of a polygon. In this, why don't you try A, B, C, D on your own, and then you can click play when you have your answers to see how you did. We have the center of the regular polygon A, B, C, D, E is going to be at point F. And when you label a point, it's just the capital letter. And identify a central angle. And remember, the central angle is between two radiuses. So a radius goes from the center to a vertex. So AF and EF would be two radiuses. So a central angle could be angle AFE. And if you named it EFA, that's the same angle, so that works as well. And then next, we have a radius, which we've already pointed out what those are, and that would be segment AF and segment FE. And remember, radius goes from the center to a vertex. And then the last one, what is an apothem? An apothem goes from the center to perpendicular to the side length. So perpendicular to the side. So in this one, an example of apothem could be FG. And if we were to find the lengths of a radius, all of the radiuses are congruent to each other. So the radius over here is 6.8, so that's going to be the length of this radius. And the length of the apothem is 5.5. So what we went over last week on 9.5 day 1, that one we had to find the length of the radius and the apothem to find the area of the triangle, and then multiply that by the number of sides the polygon had to figure out the area. Today we're going to go over something a little bit different. So we can find the area of any regular entagon by dividing it into congruent triangles, where the area equals area of one triangle times the number of triangles, which is equal to the number of sides. Another way that we can find the area of a regular polygon is by finding the perimeter and multiplying that by 1/2 and the length of the apothem. So another area formula is 1/2 times A times P. And A, remember, is the apothem. And capital P represents for the perimeter. And remember, perimeter is the area around the shape. So this is a second way that we can find the area of a regular polygon. Now let's do some examples. Example 1, you are decorating the top of a table by covering it with small ceramic tiles. The tabletop is a regular octagon with 15-inch sides and a radius of 19.6 inches. Excuse me. What is the area you are covering? So this is the picture, and we know the side lengths are 15 inches, and they told us the length of the radius is 19.6 inches. We're going to be finding the area of this octagon. So we're going to use the formula that we just went over. Area equals 1/2 times the apothem times the perimeter. And they told us that the apothem, they told us what the radius is. So we're going to have to find the apothem. So to do that, we're just going to draw one triangle section. So this triangle, we're going to draw that down there. So in this triangle, we know the side of the polygon is equal to 15 inches, so we can label that 15. And we know that both radiuses are 19.6. So 19.6, 19.6. We need to find the length of the apothem. So we're going to draw in the height of this triangle. And remember, the height cuts the apothem, or the height, cuts the base of the triangle in half. So half of 15 would be 7.5, which means both of these segments are 7.5. From this, we can figure out the height by using Pythagorean theorem. So if you look at this triangle here, we can use this as our C value, A and B, to find what the height is, or the length of the apothem. So we know 7.5 squared plus h squared equals 19.6 squared. And if we just grab our calculator really quick. Yeah, 7.5 squared is going to be 56.25. And 19.6 squared equals 384.16. And then we'll subtract that 56.25 on both sides. And that will leave us with h squared equals 327.91. And then we need to take the square root of that, and we can round to the nearest. So actually for this one, because we didn't get an exact answer, we're just going to leave the height as the square root of 327.91. And that is the length of the apothem. And we're just going to put that whole number in our area formula. And this way we're not rounding multiple times. So we're just going to plug that in there. And then we're going to multiply this by the perimeter. And we know that there are 8 sides to an octagon, and each side is 15 inches. So to find the perimeter, we're going to take 8 times 15, which is 120. So now we can just type this whole formula into our calculator. And 1/2 you can type as 0.5 times the square root of 327.91. And make sure you're no longer underneath the square root sign when you multiply it by 120. So notice this 120 is not below the bar of the square root, which means that that would be our answer. And now that this is our final answer, we can round this to 1 decimal point. So we're going to have 1086.5 inches squared for our answer. So sometimes you're going to be given the apothem and sometimes you're not. So be careful and make sure you are calculating that before you plug numbers into the equation. All right, let's move on to example 2. A regular nonagon is inscribed in a circle with a radius of 4 units. Find the perimeter and area of the nonagon. All right. So we know that the radius is 4 inches, but they didn't give us any other side lengths. So we are going to have to calculate what these angles are, and then use some trigonometry or special right triangles. So we know all the way around is a circle of 360 degrees. And if we cut each of these triangles into our nonagon, you'll notice there's 2 per side length. So there would be 2, 4, 6, 8, 10, 12, 14, 16, 18 going all the way around. So to figure out what one of these smaller angles equals, we're going to take 360 degrees divided by 18, because there are 18 equal triangles that we can form. And by doing that, we are going to get 20 degrees. So that means in this triangle, this angle is 20 degrees. Same thing with the triangle below it. And we need to figure out what the side length equals here to figure out what the perimeter is. So to help with that, I'm just going to redraw the triangle over here so we have a better visual. We know it's a right triangle with 20 degrees, and this length is 4. So we're looking for this value of x, which is the opposite side, and we know the hypotenuse, and this would be our adjacent. When we're doing this, we're going to use our opposite and our hypotenuse, which from SOHCAHTOA that would be our sine function. So when we set up our equation, we're going to have sine of 20 degrees equals x over 4. And our goal is to get x by itself. So we're going to multiply both sides by 4. And we would end up with 4 sine of 20 is equal to x. So that gives us this one little side length. And if we want the full length of this base here, we're going to have to multiply that by 2. So if we take that times 2, we would end up with the base of this, or one side length, being 8 sine of 20. And we need to figure out what our perimeter is. So our perimeter, you're going to take the side length and you're going to multiply that by the number of sides, or our n value. So our perimeter for this one, we know our side length is 8 times the sine of 20 degrees. And then we're going to multiply that by the number of sides. And this is a nonagon, so it's going to have 9 sides. And we're not going to round our answer quite yet, so we're just going to write the exact value for the perimeter. We're going to have 8 times 9 is 72. And then we're just going to keep the sine of 20 degrees. And the reason we're going to do that is so that when we get our area, we're not rounding multiple different times to get that area. So now we know the perimeter, and our area formula is 1/2 times the apothem times the perimeter. So now we still need to figure out what our apothem is, because we did already find the perimeter. Looking at this, our apothem is going to be the adjacent side that we are looking for. So we're going to set up a second equation using SOHCAHTOA, and this time we're using the adjacent and the hypotenuse, so we're going to use cosine of 20 degrees equals a over 4. And again, we want to get our variable by itself, so we're going to multiply by the denominator, and we're going to have 4 cosine of 20 is equal to the length of our apothem. And again, because we want an exact answer, we're going to leave our work like this until we type it into our equation. And we already know that this, oh, not that one, sorry. And our perimeter is going to be plugged in up here. Now that we have that, our equation for our area is going to be 1/2 times 4 cosine of 20 times the perimeter of 72 sine of 20. And the reason we're writing this all out is so our answer is as accurate as possible. We're going to do 0.5 times 4 cosine of 20 degrees times 72 sine of 20 degrees again. So our area is about 46.3, and our units for this one was just units. So this problem was quite a bit of work, But if this was a problem on a test, for example, you would get a point for finding the side length, a point for the perimeter, a point for the apothem, and then a point for your area. So this problem would be about 4 points, which on our test, they're usually about 35 points. So 4 out of 35 is worth about 11% of the test. So this one question, knowing how to do it, is very important. And that's why we're going to get a lot of practice doing them on our homework and in our examples. All right, so for the extra practice, I would like you to try those on your own, and then once you have your answers, you can press play to see if you did them correctly. So the first one, we're going to find the perimeter and then the area of the regular polygon, so just like we did before. And not all of these you're going to have to use trigonometry. Sometimes we can just use Pythagorean theorem. For example, in this problem, we have a 1, 2, 3, 4, 5. So we have a pentagon with 5 sides. And we need to find, if we're going to use the formula we went over today, 1/2 times the apothem times the perimeter. If we're going to do that, we need to figure out what this value is there. And notice that is in a right triangle. So we can just use Pythagorean theorem. And 8 has to be your C value in this. So 6.5 squared plus x squared equals 8 squared. So we'll have 42.25 plus x squared equals 64. And 64 minus the 42.25, x squared is going to be equal to 21.75. And we can see if there's a square root of that, and that one's rounded, so we're just going to leave our answer as the square root of 21.75. So we're not rounding multiple times. Okay, so that's the length of part of our base. So that would be 1/2 of it. So we need to figure out how many of those would be all the way around our pentagon. So we would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So to find our perimeter for this, we're going to take 10 times the square root of 21.75. And because we want exact answers right now, we're just going to do 10 times the square root of 21.75. And then we can plug that in for our p-value. And we are already given the length of our apothem, so now we have everything to put into our formula. And area equals 1/2, 6.5 times 10 times the square root of 21.75. And this is where we can type it into our calculators. And this is when we can round to 1 decimal point. 21.75. Perfect. So we're going to have 151.6 units squared. So that is the area of number 3. Now we can move on to number 4. Okay. This one, they don't really give us much, except that a side length is equal to 7. So first, it might be easiest if we figure out what the perimeter is, which is going to be 7 times the number of sides, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have a dodecagon. And our perimeter is equal to 70 units. Now we need to figure out what the length of our apothem is. So if we were to pull out from the center one of these triangles, we can draw it off to the side. So we know we have one triangle, And we know the base is 7, and if we were to cut that in half by our apothem, it would be 3.5 and 3.5. And we need to figure out the length of this apothem. We're not given any other side lengths, but we can figure out what the top angle is in this triangle. So if you remember, all the way around a circle is 360 degrees. 360 degrees. We want to figure out what half of a central angle equals. So if we were finding the length of a central angle, we would just divide this by the number of sides. But we want to figure out what half of that is. So each side length, we can form 2 of these angles. So we're going to take the total number of sides and multiply that by 2, which would be 20. And that's what we're going to divide this 360 by. And that will give us 18 degrees. So each one of these little angles up here is 18 degrees. Well, that's kind of hard to read, so I will write it over here. So that angle is 18 degrees. So looking at this, we're just going to use one of these right triangles to figure out what the apothem is. We know that we have the top angle, and from there we have our opposite side and we have our adjacent side. Looking at SOHCAHTOA, the one that uses opposite and adjacent is our tangent function. When we write that out, we would have tangent of 18 equals 3.5 over A. And at this point, we can go ahead and cross multiply, and we would get 3.5 equals, and when you take a number or a variable multiplied by a tangent function, that value is just going to go in front. So we're going to have a tangent of 18. And our goal is to get a by itself, so we're going to divide both sides by the tangent of 18. And that will give us the length of our apothem as 3.5 over the tangent of 18 equals A. And now we have everything we need. We have our perimeter and we have our apothem. So now we have all the information to find our area, which is 1/2 the apothem, 3.5 over the tangent of 18 times the perimeter of 70. And we can just go ahead and type this into our calculator. So we'll have 0.5 times 3.5 divided by the tangent of 18 times 70. And that is our area of this decagon. And that will be 377.0 units squared. And that is our final area. Okay, so if you didn't get that one correct on your own, make sure you get all of the work copied down so that you have it as a reference when you are looking back after your from your homework. And our last one, we are finding the area of this triangle inside of the circle. So we know we have one triangle. And this one, they already give us the length of the apothem. So we know right away that A is equal to 5 in our area formula of 1/2 times A times P. So now we just need to figure out what the perimeter is. So that's what we are looking for here. In our triangle, we can extend a radius. So we have a right triangle there. And remember, there would be a total of 3 radiuses in a triangle. So to figure out what this central angle here is, we're going to take 360 divided by 3, and that's 120. But we want to figure out what half of it equals. So then we're going to divide that by 2 again. So we'll take 120 divided by 2, and that would be 60 degrees. still on the eraser there, sorry. 60. So another way to do that is because we have two of these smaller angles in one of the triangles, we would have 2 over there and 2 there. We could have just taken 360 divided by 6 to start with and gotten that smaller angle. To help as a reference, I'm just going to draw that triangle, this half of one, over on the right so that we have more space to look at it. We know this top angle is 60, which means this one is a 30. So right away, we should identify that this is a special right triangle, 30, 60, 90. And if you don't remember, we have our short leg, our hypotenuse, and our long leg. And our long leg is equal to the short leg times the square root of 3, and our hypotenuse is our short leg times 2. So we can find all of the side lengths by using our special right triangle. So this one's our hypotenuse, and this one is the base of our long leg. So our hypotenuse is the short leg times 2, that would be 10. And our long leg, y, is equal to the short leg, 5, times the square root of 3. Now we already know all of our side lengths just by using that special right triangle. No trig required. Okay, so now we can find our perimeter. We know that this 5 square roots of 3 is just half of one of the sides. So if we count out the total number of sides that we would need, we would have 1, 2, 3, 4, 5, 6. So to find our perimeter, we're going to take 5 square roots of 3 and we're going to multiply it by 6. And when we do that, remember you just multiply the whole numbers together, so that would be 30, and we keep the square root of 3 with it. Now we have all of the information we need to find the area. So our area is going to be 1/2 the length of our apothem, which they gave us is 5, times the length of our perimeter, which is 30 square roots of 3. And our area for this one, 0.5 times 5 times 30 square roots of 3. And notice we didn't round any of our answers until we got to our final value. And there we go. If you have any questions on these problems, let me know and I will get those answered for you as soon as possible. But that should be everything you need to complete the homework. And you can use either this equation to find the area, 1/2 apothem times perimeter, or you can find the area of the triangles and then times the number of triangles. Whichever one is easier for you to find the area, but both will give you the correct answer. And remember, don't round until you get to the very end of your problem.